Hello friends, welcome to this video on understanding a cube. A cube is a three-dimensional structure that gets developed out of a square in two dimensions. So when this two-dimensional square is projected or is going to be visualized in a three dimension, we get a cube. This video will help you to understand a cube in a better way in three dimensions. Its surfaces, its unit vectors and its equations. Come, let's watch this video and get to understand the cube in a better way. So this is going to be a three-dimensional view of a cube. Now when it comes to a cube, we have a three-dimensional axis which is going to be x, a y and a z. It is customary to make use of this axis as x, the second one as y and the top one as z. A cube is going to be made up of 6 faces. So a solid 6 face is going to construct the structure called as cube. Now when we can see a cube in this way, we can name these faces as a front, a back face, a left face, a right face, a top face and a bottom face. Now these are going to be my 6 faces of the cube. What about the ordinates? Now say suppose this cube is going to be formed by making use of 6 planes. Say suppose they are going to be x equal to 0, x equal to a, y equal to 0, y equal to a, z equal to 0 and z equal to a. How to position the ordinates of these points over here in this diagram? The one which is in the center will now denote the origin, which is given by the triplet 0, 0, 0. At this position O or the origin, the value taken by x-axis is 0, y-axis is 0 and z-axis is 0. Now when we are going to move a units in the direction of x, we will be reaching this point over here, which is given by the coordinates as a, 0, 0. Why it is going to be a in the x? Because we have moved a units in the direction of x. So this point will be denoted by a, 0, 0. Now in a similar fashion, let us move a units in the direction of y. In which case, what will happen to this point over here? This point will now be denoted by the value 0, a, 0. The 0 over here stands for x. It has 0 units in x direction, a units in the y direction and 0 units in the z direction. This is because we moved a units in the direction of y, hence the y coordinate alone changes to a. Now let us move a units in the direction of z. If I move a units in the direction of z, I will be reaching this position over here, which is given by 0, 0, a. This means I have moved 0 units in x direction, 0 units in y direction and a units in my direction of z. Now if we are able to fix these ordinates properly, then fixing the limits in our integrals will become much easy for us. Now let us explore all these 6 phases in detail. Moving on to the next slide, we have this front face which is facing near you in the direction of x and one at the back face of this z. Okay, so how to represent this one which is going to face in front of you and one that faces in back of you? So this represents the face, a front and a back. The back one over here, which is attached towards the wall, which has z and y as its base, is called or referred by the name ZY plane. and the name of the ZY plane is called as x equal to 0. So this face, which is pink in color at the back, is called by the name x equal to 0. Now, when I move a units in the direction of x from the back wall to the front, so this will be my back, and if I move to the front, so in the front, how much units I have moved? I have moved a units in the front. So this position, which is being bounded by the dark red color, represents your front face, and it is given by the equation x equal to a. So we have now defined two phases of the 6 different phases, a front and a back. The back is given by x equal to 0 and the front is given as x equal to a. Now considering the unit vectors in this direction. Now always in the direction of x, the unit vector is denoted by I cap. The unit normal vector in the direction of I is x-axis is going to be I cap. Hence, what happens over here is for the face x equal to a, which is going to be in front, the unit outward drawn vector or your n cap will be equal to I cap, or it is going to be I vector. And the one which is in the back, for the front you have it as x equal to a, for the back we have it as x equal to 0. So what will be the unit outward drawn normal? So unit outward drawn normal in the direction of x is moving towards you, and the one which is going to be outward drawn normal will move in the opposite direction, that is in this way. Okay, so if it moves in this way, this vector is going to be denoted by minus I vector. So for the back face x equal to 0, my unit outward drawn normal will be denoted by minus I vector. So we have defined what is going to be the name of the front face, which is given as x equal to a. The back face is given by x equal to 0. The unit outward drawn normal in the direction of your x equal to a is the positive I cap, and the unit outward drawn normal in the direction of your back will be equal to minus I. Next, let us move on to the next surface. The next surface is one in the orientation of y. Now, in the orientation of y, we call these two faces by the name a left and a right. So, what is going to be the equation of the face which is light blue in nature? This is going to be formed by the zx plane. This zx plane is now given by the value y equal to 0. So, the plane in our left is always represented by the equation y equal to 0. Now, if I move a units in the direction of y, I will be reaching this plane in the dark blue color, which is going to be in the right portion of it. So, I have moved a units in the y direction. So, this dark blue plane will be called by the name y equal to a. Now, how about the unit vector in the direction of y? In the direction of y, the unit vector is going to be j cap. So, for the plane y equal to a, the unit outward drawn normal will be equal to j cap. And in the case of y equal to 0, your unit outward drawn normal will be pointing in the opposite phase of yours, and hence if this is going to be j, the outward drawn normal over here will be minus j cap. So for the left face, which is represented by the equation y equal to 0, your unit outward drawn normal is minus j, and for the right face, which is given by y equal to a, the unit outward drawn normal is going to be j. Now moving on to the last phase. Now this is in the direction of z. Now we are going to analyze the name of these phases. Now we have completed a front back, a left right, and now this comes to a top and a bottom. So this now defines my phase number 5 and phase number 6. Now at the bottom I have x and the y-axis, and this phase which is at the bottom is represented as z equal to 0. So the bottom phase will be represented by the equation z is equal to 0. If I move a units above my z equal to 0 plane, I will be reaching this above plane which is darker yellow in nature and is given by the name z is equal to a. Hence, the top surface of the cube is represented by the plane called as z is equal to a. So, the equation for the bottom plane will be z equal to 0 and the equation for the top one will be z equal to a. Now, considering the unit outward drawn normal, the unit vector in the direction of z is given as k cap. So, for the top surface, we have my unit vector to be equal to k vector or k cap. Now, considering the bottom quantity, this is going to be the phase z equal to 0. Your outward drawn normal will be drawn in this direction, that is moving inside the flow. So in which case it is opposite to the direction of k and it is denoted by minus k cap. So the unit outward drawn normal for my bottom will be represented by minus k vector or minus k cap. Now keeping these 6 phases in mind, we will quickly recollect what are they going to be equal to. The front and the back. The front one called as x equal to a with I cap as the unit vector. The back one called as x equal to 0 with minus I cap. The next comes your left and the right. The left one with y equal to 0 having unit vector minus j cap, and the right one having y equal to a with unit vector j cap. And the last one is going to be your top and the bottom phases with z equal to a on top with k vector as the unit outward drawn normal, and the bottom phase with z equal to 0 with unit outward drawn normal to be equal to minus k. Now this 6 phases entirely defines your cube. Now if it is going to be applicable for an open surface, so the box is going to be open to one of the phases, then ignoring those quantity, we will be having, or the cube will be covered by 5 different phases. So depending upon the question, check on which is going to be the surface which is removed and then fix your limits accordingly. Now fixing the limits as such for a 2 dimension, whenever we have the surface for the integration of my x, so I have integrated with respect to x, therefore my surface integral ds will be with respect to the remaining left out variable, which will be double integral dy dz. The order of integration over here is immaterial because if it is going to be a constant limit. Therefore, the surface integral for my x plane will now be given by double integral dy dz. Now my y can vary between 0 to a and my z can vary between 0 to a. So this can be evaluated for your double integral. Now coming to your y-axis, what happens over here is we have the ds to be the surface integral. Y has been cut off over here, hence your double integral will be a function of dx and dz. Now ds will be integrated with respect to x and with respect to z. Now coming to your third phase, your ds over here, the surface integral, will be with respect to the left out variables. So z being removed, we will be integrating with respect to dx and dy. Now this can be immaterial of the order of integration, like it can be taken either dy by dx or dx dy depending upon the integration you feel comfortable, because the limits are going to be constant in all the ways. When it comes to triple integral, a volume integration, the volume will now be integrated for 3 integrals, dx, dy, dz, where x varies from 0 to a, your y varies from 0 to a, and your z also varies from 0 to a. I suppose that this video will now be helpful for fixing your limit of integration, to know the phases on which you are integrating, and to fix the unit vectors to be drawn or to be identified in that particular direction. So just keep this in your mind. The 6 faces are going to be front, back, left, right and top, bottom with their corresponding equations: x equal to 0, x equal to a, y equal to 0, y equal to a, z equal to 0 and z equal to a. Thank you.